So what we're going to do today is to dissect a chicken. So this is not a common fowl or a layer. This is one of the chickens that we use for ordinary consumption. So basically this guy has been bred to be eaten. So certain things that we would probably see in the common fowl in your yard, or the layers that your family will sometimes cook in a curry stew with some dal and rice as a special treat. The meat here is always very soft. It's a lot of white meat, and you generally don't see the reproductive organs well developed. But today we're focusing on the digestive system and on the parts of this chicken that are necessary for processing food. Okay, so the first thing is we look at the mouth. So I told you all that if you give me the head of any animal, I can give you a very easy, a very precise guess as to what it ate, right? So this chicken here, with digestive system starts at the mouth. The beak is the first part of the digestive system. So this beak is very sharp and it's curved, and what this chicken does, it basically pecks to pick up on grains and small materials. So the digestive system, the mouth, leads to the, what does the mouth lead to? Leads to the esophagus, right? So because this is freshly killed, we're still seeing a little bit of regurgitated food material here. The tongue is more, it's a hardish structure here. It's more for manipulation of the food backwards into the gullet, as opposed to a tasting and mixing organ that we see with our teeth, with our mouths, right? This is because the chicken does not really keep a lot of food in its mouth for a long time. When you think about how we eat, we're going to take a bite of food and then get it nice and wet with our saliva, chew it up, break it down into smaller pieces, get it into a nice tight bolus, and then we will swallow. This guy here, his digestive system, or her digestive system, is basically geared towards getting as much food in as possible, right? So it's basically just going to stuff its gullet literally. And we will see when we look at the upper digestive system of the chicken exactly what that means. Now, before we go on to actually cut the chicken open, we want to take a little look at the feet and the claws of the chicken. So this tells us, the feet of birds tells us a lot about how that bird is acquiring its food and how it lives. So for example, a hawk or an owl is going to have very long curved talons that will be geared to grabbing its prey, right? This chicken, its nails are geared to scratching in the dirt to stir up bugs and to stir up little grains and little bits of things that it could scavenge to eat. So we are now going to cut this guy open. So when we're dissecting a vertebrate, we normally cut ventrally. So we cut basically up the belly, right? When we're cutting an invertebrate, we cut dorsally, so we'd put it face down and we'd cut the back. But for a vertebrate, because you have the vertebral column blocking most of the organs, and that vertebral column, you can't easily remove it without causing some serious damage. We do not cut dorsally, we cut ventrally. Now, the chicken is going to be a little different. Normally when we're doing, so if I were cutting open a frog, for example, I would cut up the mid-ventral line to go through the middle of the frog. However, because this chicken has this huge big block of breast meat here, which is the flight muscle, where it has the flight muscle, or what would be the flight muscle in a flying bird, it's difficult to cut through here in order to get to the digestive system or the innards, into the visceral organs. So what we do, we're going to start cutting up, and then we're going to cut around and fold it open like a book. All right. So I'm going to start cutting. Can I get a pair of forceps, please? All right. So we're going to start at the cloaca of the bird. So the cloaca is a common opening to the reproductive, digestive, and urinary tracts that you see, thank you, in birds and reptiles, right? So they do not have a separate opening for defecation and for giving birth and for urination, as you see in mammals, right? In the true mammals. We have a cloaca. So this cloaca serves as a common opening for the digestive, reproductive, and urinary tracts. But like I said, this guy here was not bred for breeding purposes. This is a what do you call him again? This is one of the chickens. Broiler. A broiler, yes, thank you. A broiler. I forgot the word for broiler. This is a broiler, so it is basically all about just packing on pounds to be eaten by a hungry family. Okay. So I'm sure there are people who are able to get a chicken open in a matter of seconds. In fact, my first knowledge of dissections used to come from looking at my mom cut meat for cut and season meat. Right? I used to be at her elbow every day while she was doing her kitchen chores. Helping, like if she needed somebody to hand her the salt or hand her the this or hand her the other, I was there. And she always had a very keen interest in biology, so she was very happy to help me identify or point out different parts of the digestive system for me. Okay. So with any dissection, you're going to be a little surprised at how tough skin is. Right? It takes a little work to get through the skin, and skin, as we will see in some of our lectures, is a very layered structure. So what I'm going to do is just cut through the skin here and fold it back. Right. So note that the skin is held in place, held to the muscle below by these connective tissue strands, right? So we're folding it back. And you can actually see some veins on the skin because the skin has to be vascularized as well. As we will see when we're looking at temperature regulation, skin is a majorly important part of keeping our bodies warm and getting rid of extra heat. Right? So I folded the skin back, and you can see the large block of breast meat, right? So this large block of breast meat is supported in the middle by the piece of cartilage. So when you go to KFC and you buy your center breast, that piece of cartilage in the middle is basically there to attach these two halves to this massive block of flight muscle. Okay. So I'm going to cut around. Remember, normally I would cut up the middle of the animal, but because this block of breast meat is so huge, I am cutting around, and we're going to open it like a book. Okay. So this is where it starts to get a little dicey. So these membranous structures that you're seeing here are some of the air sacs being ruptured as I cut. Right? There's no getting around that. Okay. I'm gonna cut open here a little more. Oh. So this guy has had a very, very big meal recently, and we'll talk about that in a little bit. Now, of course, if you are a meat eater, something you could do is buy one of these and cut them open, or buy a fish and cut it open to just get an idea of what it is that goes into making an animal function in food acquisition and processing. Okay, so that was some lung. This red structure, very red, dense structure that you see here, is the lung, right? And remember from last year, we said that the lung is not like our lungs that stretch open. It basically is a structure that is densely packed against the ribs, and its sole function really is just to get gas exchange to happen. The ventilation in the chicken happens via the air sacs. Okay. Okay. Let me get here open a little bit so I can. Okay. So one of the things that chickens do, if you've ever looked at chickens' feed, they are basically going to be pecking at the ground and picking up their food very, very quickly, right? They don't really stop to chew and think about life or anything. Their whole purpose is just to get their food as quickly as possible. So that food goes from the mouth into the esophagus, and then, so the esophagus is, that's the neck there, which some people consider a delicacy. Right. So you're seeing two tubes here. This tube that's a little firmer and more rigid, that's the trachea, so that's for the airway. And this soft squishy tube here is the esophagus. So food for the chicken is going to enter, after the mouth, it goes through the esophagus, and then it's going to enter this structure here called the crop. What this crop is basically doing, the crop is going to be a store of the food material. So the food is going to be stored in that crop, and then eventually it'll be passed to the rest of the digestive system. Okay. I'm trying to do this without cutting into the digestive system. All right. And of course, a busy cook would have had this drawn and quartered by now, right? Okay, so this crop is actually full of food, of grain, of the chicken feed, okay? And it's probably going to smell like death if I open it, so I'm trying very hard not to open it. Okay. All right, right. Okay. So you know, like when you do a full chicken, you roast a full chicken at home, you get this wishbone. I'm trying to cut through that now. That wishbone is called the furcula, and that helps to support that massive block of flight muscle. So even though the chickens do not really fly, they still have that massive block of muscle. Let's try another approach. Without taking a hatchet to it, I have to go in from the other side. Okay. So one thing that I would like us to appreciate, you know, we think of chicken, of breast meat as being white meat, right? If you were to cut into a duck, for example, this breast meat is going to be brilliantly red, very, very richly red, because it is actually powering flight, right? Because our chickens that we're familiar with are kind of red and bred to be soft and white meat. You know, that is something we kind of don't really appreciate, that the flight muscles have to be very vascularized, so it has a ready supply of blood going to it. Okay. So again, I'm just trying to clear this massive block of breast meat off. This is going to sound gruesome. And you might hear me yelp in distress a little, because even though I do this, it's not something I have a lot of fun doing. It's interesting, and I can make a separation between the science and the grossness of it, but it's not a very easy thing to do. Okay. So if we look here, we see that this is where the trachea is going to be branching to the lungs, right? This kind of ridge structure we're seeing, remember the trachea is supported by cartilage rings, and it actually has like a kind of ridge, you know how a washing machine hose feels, or a dryer hose, how it's kind of fluted and ridged. That's what it kind of feels like. Okay, so let me see if I could find. So we have our crop. I don't have the arm strength to break the joint there. Okay. So we have our crop. I'm going to expose this a little more. Right. And again, the crop is for storage of the food. And some birds actually, they have some digestive function happening in their crop. And they will eat, go and eat, and then fly back to their nests and regurgitate food into their offspring's mouths, right? And that's food that has been stored in their crops. And some birds, like pigeons, actually produce something called crop milk, where enzymatically the food is broken down and stored in the crop, and this digested food passes to the offspring. So if they had starved this bird beforehand, this crop would be like a flap of skin, right? Because it's basically just a sack. All right. So food goes down the esophagus, right? So the esophagus here, let me clear the esophagus for us. So this tube here is the esophagus, right? And thanks to my mom, I could tell these little flaps of flesh from each other. She basically reared me to be a biologist. So after the crop, the food is then going to go to a structure known as the gizzard. So here we have, okay. So one thing that I would like for us to appreciate is how neatly everything is tucked away in the body. It's not like when you look at the dissections or you look at a picture and you see everything neatly arrayed. You have bits of connective tissue covering the important parts. So remember that the chicken does not have teeth. Chickens do not have teeth. In fact, there is an adverb as rare as hen's teeth, because teeth would be a very odd thing to find in a chicken, right? So where does this food get broken down? Okay, this here is the liver, right? I'll continue to break it open as we go along. But what I want you to note is that liver, again, always has this very distinguishable appearance. Right? It will always lobed with these smooth edges, these smooth rounded edges, and it's always very dark in color, partly because of blood, the blood that's running through the liver, and partly because of all of the bile. If I were to move the liver back, you would see a green tinged sac. Oopsie, that is the gallbladder. Cut here a little more. Right. So I actually accidentally cut through the digestive tract here. So this is the digestive tract that's leading to down here, down here we have our gizzard. This here is the heart, right? So that's our chicken heart. Down here we have our gizzard. Right. So I'm cutting through some layers of fat, and you know that when you're cutting up your chicken, when you're cleaning your chicken, you have to basically get all of this fat out, right? Okay, so I was talking about the gizzard. What this gizzard does, it basically replaces teeth in the digestive system of the chicken. We chew our food. We break our food down by chewing, but birds, again, do not have teeth. So what they do, they will ingest stones and store them in this very muscular sac called the gizzard, right? If you've ever eaten gizzard, you know that it has a very, very chewy texture. That's because it's very, very, very muscular. We'll cut it open as we proceed. And what that is doing, it's going to grind those stones against the grains that this bird will eat in order to break the food down into smaller parts. Okay, so I am going to and we're starting to see some intestines here as well. So the structures that hold the bits of the intestine together are called mesenteries, right? And fairly recently, they designated the mesenteries in our bodies as being a distinct organ on its own. The mesenteries, as you remember from our class last week, I don't know when you're going to view this, but our first class of the digestive system, the mesenteries are made up of connective tissue and they're highly vascularized, right? So you're seeing that the liver is always very closely associated with the gallbladder because the gallbladder is storing the bile from the liver, right? And so one thing that you won't get with a virtual dissection is the smell. It can be a bit forbidding. I mean, we're scientists, so there are certain things that we just deal with. So one strategy when you're doing dissections and the smell disturbs you, you can actually put a little bit of Vicks in just at the opening of your nose. So you will get the smell of Vicks overwhelming the smell of what you're cutting open. Okay. All right. So behind the liver, I'm told that actually a lot of new medical students, when they're doing their cadaver studies, that's one thing they do. They put Vicks in their noses to get away from the smell. But when you've been doing it for a few years, you get accustomed to it. So, like if I were doing dissections every week, it's not going to bother me because I would just develop the mental space where whatevs, it's just going to be one more step that I don't need to do if I acclimate myself. However, this is the first dissection I'm doing in a long time, so the smell is going to get to me a little. Okay. Right. Okay. So we're tracing back from the esophagus, from the esophagus it goes to the crop and then down to the stomach here. So the stomach has a digestive function, yes, an enzyme secretory function, but it does not do much mechanical digestion as you would see in the mammalian system, right? And I think that's kind of like a cool adaptation that you have this whole muscular sac that's going to be grinding the food. So from the stomach to the crop, and then from the crop to the small intestine. So the associated organs we have here, we have our liver. Liver always has this very distinct appearance, and the gizzard, is the mechanical digestion site, right? Crop is for storage, gizzard is for mechanical digestion. Right, so if you are anemic, one of the things they will tell you to do is to eat liver, right? Because liver has a lot of iron in it, it's highly because of the highly vascularized nature, it has a lot of blood, so it's something that is thought to be very, very good for anemia. If you eat mammals, then beef liver is probably the most nutritional value that you could get for an anemic person. If you don't eat mammals, then chicken livers are fine as well. I personally cannot get around the texture. So whenever I end up with a little piece of liver in my plate, I usually just pass it to my brother, who loves the liver. Okay, so we have our liver, we have our gallbladder, which is green, right? So the gallbladder is all about storing that bile to break down, to emulsify the fat, right? And to change the pH from the stomach into the intestine. What is the pH of the stomach? You remember the pH of the stomach is always acidic. The small intestine is an alkaline environment. So secretions from the liver and secretions from the pancreas are going to neutralize the acid of the stomach contents to make it a more basic environment. So this little ball that we have here is the spleen, right? So that little red ball, this red ball here is the spleen, gallbladder, liver, gizzard, right? And all of this is a small intestine. This stripe of tissue, creamy looking tissue that you see between these two loops of the small intestine, right? So after the crop, it comes, this loop goes up and then it comes down like this with a stripe of creamy tissue in the middle. That stripe of creamy tissue is actually the pancreas here, right? And you can see the blood vessels. This all is very highly vascularized. The pancreas has a lot of secretions that help to neutralize the contents of the stomach, and also to, it contains a lot of enzymes for breaking down the sugars. Okay. And some proteases as well. And then, of course, you have your small intestine, right? And you can see your blood vessels, because this is a very absorptive structure. So you have a lot of blood vessels that are going to be carrying food, digested food, in the blood vessels back to mainly the liver, from whence it will go to storage and to the rest of the organism, to the heart for distribution to the rest of the organism, right? So we could cut out all of these mesenteries and spread the intestines out, so you will see how long they are, but I want us to appreciate how vascularized and how organized these mesenteries are. Okay. So after the small intestine, we have a very short, large intestine, and just at the junction of the small intestine and the large intestine, we have these structures called Sikhi. So actually, what I'm going to do, in fact, I will tease out the intestine for us. Okay. So we noted the mesenteries, and now I'm just going to cut them apart to spread this out. I'm leaving this one in the loop to keep the pancreas intact. And then from here, I'm just going to, I am so grossed out. Right. I'm going to cut all of this open. All right. So note that this is some really good packing going on in here. And then we come down to this part here where we have these two kind of out pocketings off the intestines. Those are Sikhi, right? So Sikhi are usually very well developed in hind gut fermenters. And chickens, yes, do eat their own poop to get some of the cecal digestive products, right? The Sikhi will have an intestinal flora of bacteria that is going to help to break materials down, right? So these Sikhi branch out where the small intestine meets the large intestine, right? Okay, so you see these are the Sikhi, and you can see the tube of the small intestine is going continuously down to the large intestine, right? And then you have these branching pockets, the Sikhi, okay? And then your large intestine here is very, very small, well, not very long, and it ends with the cloaca. So this is where the cloaca ends. So if I were to stretch out the intestine, you see that all of this was neatly packed into the body cavity of your chicken, right? It's a fairly long intestine for breaking material down. Now what I want us to do is to extract this gizzard, and I'm gonna see if I could cut the gizzard open for us. I'm an extremely, extremely spoiled person, so I don't eat gizzards, right? But like when I'm helping my family prepare meat, like I'm helping out my sisters-in-law and stuff, and they're like, well, you could season the chicken, what needs to be done? You could season the chicken. And I have to cut open the gizzard. It's always like very interesting to me. Okay. You can help me open scalpel, please. Right. So I'm going to move the carcass aside and we're going to focus on this gizzard a little. So you see how hard this gizzard is, right? And you know, gizzard is something that has to cook down for a while in order for it to be edible. That's because it has a massive amount of muscles. We have a tube leading in, a tube leading out. Thank you. Okay. So I'm going to use my trusty scalpel and cut into the gizzard. And again, because my brothers love liver and gizzard, I would go through this in preparing their food, because otherwise, Okay. So, we've cut this open. Look at how thick this muscle wall is. And this material here in the middle, that's the food material that has been ground up by the thick muscular wall of this gizzard. So let's do this without me slicing a finger open. The smell is appalling. Just saying. You know, at cooking shows, they always tell you what the smell is like. So I'm doing that for you right now. Okay. So the inner wall of the gizzard is very fluted as well. Right? You know, if you're preparing this for cooking, you have to basically peel that inner layer off. Right? So it's ridged, it's fluted, it's very, very rough. It's actually rougher and tougher than the skin on the actual skin of the chicken. If you've ever prepared gizzards for cooking, you know what I'm talking about. Right? So that's where the food is ground up to be passed on to the rest of the digestive system. Right? So that's the digestive system of our chicken. I hope you enjoyed this because it really is interesting. You know, when you could put aside the feelings of this is not fun, it's very interesting to see how the organs connect to each other and to know what their functions are. Right? This is one of the reasons why I still do biology, I still do dissections, and I value dissections because it gives me a great appreciation of how things are connected and how they work together to function. And that's not something you can get from just reading a book. All right, so that's the end of the dissection of the chicken.